Picture this. You're building a feature in Android Studio. You ask your AI assistant for help with a StateFlow-based view model, and it hands you back code using LiveData from 2019. You ask for a coroutine, and it gives you an RX Java observable. Sound familiar? The problem isn't just that these models don't know Android. The problem is that Android evolves fast, and most AI models are stuck 3 years behind. Jetpack Compose replaced XML layouts. StateFlow replaced LiveData. Structured concurrency changed how we write async code. So in this video, I'm going to test 4 open source models on real Kotlin and Android tasks and show you which one you should actually trust. No synthetic benchmarks, no theory, just real code, real architecture, and real results. We have 4 contenders. First, DeepSeek V3.2, currently the top-rated open-source coding model, strong on general programming tasks. Second, Qwen 3 Coder from Alibaba, built specifically for large code bases and multi-file understanding. Third, GLM 4.7 from ZipU AI, known for strong reasoning, excellent for debugging. And fourth, Llama 4 from Meta, fully runnable on local hardware, completely offline. All 4 are open source. All 4 can be run locally or through cloud APIs, and all 4 make different trade-offs that matter specifically for Android development. I'll walk through each model, show you what it gets right and what it gets wrong, and where to use it in practice. Then we'll cover prompting strategies and the local setup that actually works on a Mac. Before we score the models, let's understand why Kotlin and Android is actually a harder problem for AI than most codebases. Most AI systems do fine with isolated stateless functions, but Android code lives in a world of state machines. Lifecycle-aware components mean your view model survives screen rotations, but your fragment doesn't. Get that wrong and you get crashes that only appear after rotation. Coroutines with structured concurrency mean you need to know which scope to launch from, and using the wrong scope causes memory leaks or silent task cancellations. Jetpack Compose has its own recomposition model that's completely different from XML and view binding. Gradle keeps changing its syntax, plugin system, and dependency resolution every major version, and Android APIs get deprecated constantly. What was best practice in 2021 is an anti-pattern in 2025. A model that doesn't know these distinctions will confidently generate code that compiles but crashes at runtime, leaks memory, or causes subtle bugs that are extremely hard to track down. DeepSeek V3.2 is the strongest open source coding model right now, and it shows clearly on Android tasks. When you ask it for a view model with StateFlow and the repository pattern, it gets the architecture right. Suspend functions in the repository, a StateFlow in the view model, collected in a composable with launched effect. The pattern is modern and correct. It knows the difference between view model scope and lifecycle scope, and it doesn't confuse them. It understands clean architecture, use cases sitting between the view model and repository. If you ask it to refactor old code from LiveData to StateFlow, it does it cleanly and completely. It's not perfect. It occasionally generates slightly outdated Compose APIs, but it's consistently better than any other open source model at Kotlin idioms and Android architecture. If you're picking just one model for Android work, DeepSeek V3.2 is the safest bet. It doesn't require heavy handholding, it rarely generates architecturally broken code, and the output quality is close to what you'd get from paid tools. Qwen 3 Coder from Alibaba does something DeepSeek struggles with. It understands your whole project structure, not just the single file you pasted. When you give it multiple files, a view model, a repository, a use case, a data model, and a Gradle config, it sees how they connect. It won't suggest a breaking change to your repository interface without updating the view model that depends on it. It handles multi-module Android projects better than anything else in the open source space. If you're working on a real production app with feature modules, a shared domain module, and a separate network layer, Qwen 3 Coder is the right tool. It also handles Gradle syntax correctly, Kotlin DSL, version catalogs, dependency constraints. The downside is that it's a larger model, slower to respond, and needs more context to work well. For writing a small isolated feature, DeepSeek is faster and sufficient. But for architectural work that touches multiple layers of your code base at once, Qwen 3 Coder is the right choice. GLM 4.7 from Zipul AI has the best reasoning capability of the four, and that makes it the best debugger. When you paste a crash stack trace and ask what's wrong, GLM 4.7 doesn't just read the last line, it traces the full call chain, identifies whether you're looking at a lifecycle timing issue, a null reference in a composable, or a coroutine that outlived its scope. It's particularly good at Android-specific errors that other models misdiagnose. Illegal state exception in fragment transactions, cancellation exception being swallowed in a try-catch, or a flow that never terminates because it was collected on the wrong dispatcher. The downside, GLM writes slightly more verbose code and sometimes uses older Kotlin patterns for straightforward tasks. It's not the model you want for writing new features from scratch. The output is slower and wordier than DeepSeek. Think of GLM as your debugging partner. Use it when something is broken and you can't figure out why. Llama 4 from Meta is the only model in this comparison that you can realistically run fully local, fully offline, on consumer hardware. A 4-bit quantized version runs on a Mac Studio with 64 GB of unified memory without issue for basic Android tasks. Simple Compose layouts, straightforward repository implementations, standard view model patterns. It works. The output is usable and you won't be embarrassed by it. The problem shows up in advanced scenarios. Ask it about the difference between StateFlow and shared flow and the answer gets fuzzy. Ask it to implement proper structured concurrency in a complex use case and it defaults to global scope. Ask about Kotlin's inline functions and generic reification, and you get partial, sometimes incorrect answers. Llama 4 is a good tool for quick autocomplete on patterns you already know. It is not a reliable tool for writing new architecture or debugging subtle bugs. Use it with clear eyes about its limits. Here's the uncomfortable truth. All four models still make the same three categories of mistakes on Android code. The first is lifecycle errors. Models frequently generate code that accesses a fragments view after it's been destroyed. A classic crash that's hard to reproduce in unit tests. The misplaced coroutine launches in wrong scopes and they fail to cancel subscriptions properly when the lifecycle ends. The second is outdated APIs. Models will confidently suggest async task which was deprecated in API level 30. They use find view by ID when compose should be used. They suggest deprecated constraint layout attributes. This isn't incompetence. Android moves fast and training data has a long tail. The third is wrong coroutine scope. This one causes real production bugs, launching on global scope instead of view model scope, not properly handling cancellation exception, mixing dispatchers.io and dispatchers main incorrectly. Know these three failure modes. Verify for them on every generated code block. With that habit, you can use any of these models safely. The single biggest factor in getting good Android code from any of these models isn't which model you pick, it's how you prompt it. You need to explicitly state your tech stack in every prompt. Without this, models default to older patterns because older patterns are more common in training data. Start every prompt with 3 lines, Target the latest Android SDK, use Jetpack Compose for all UI, and use StateFlow and Kotlin coroutines, not LiveData, not RxJava. Add your architecture constraints, MVVM with clean architecture, repository pattern with use cases. If you're working in a specific module, paste the relevant interfaces. These three techniques, explicit stack declaration, architecture context, and relevant interface signatures, will improve output quality from any model by more than switching to a different model entirely. I've seen DeepSeek generate better Android code than a paid Copilot subscription simply because the prompts were better structured. The model is only half the equation. Your prompt is the other half. If you want to run any of this locally on a Mac Studio, here's the realistic picture. For Llama 4 quantized, you need at least 32 GB of unified memory. 64 GB gives you room for larger variants. Install Ollama 1 command with Homebrew and pull the model you want. Response time is 2 to 4 seconds per typical code snippet. That's acceptable for quick tasks. For DeepSeek smaller variants, the 7 and 8 billion parameter versions, Ollama handles them fine on the same hardware. Quality drops compared to the full cloud model, but it's still better than Llama 4 for most Android tasks. The full-size models, DeepSeek V3.2 at 685 billion parameters, Qwen 3-coder at 205 billion are run on consumer hardware. You access those through their cloud APIs, which are fast and inexpensive. Local is for speed and privacy. Cloud is for quality. Pick accordingly. The workflow that actually works in practice, the one most senior Android developers are quietly adopting, is a hybrid approach. Local models handle the fast, low-stakes tasks, completing a data class, generating a simple composable, translating a Java snippet to Kotlin, writing a boilerplate repository stub. These are cases where you want instant response. You don't want code leaving your machine, and the quality bar is low. Cloud models, DeepSeek V3.2 or Qwen 3-coder, handle the high-stakes tasks, designing a new features architecture, refactoring a domain layer, debugging a production crash, reviewing a complex coroutine chain for correctness. The split is roughly local for autocomplete speed, cloud for anything architectural. This isn't a compromise, it's actually better than using one model for everything, because you're matching the tool to the task, and the combined monthly cost is lower than most Copilot subscriptions. Here's the bottom line. If you want one model for all Android work, DeepSeek V3.2, it handles modern Kotlin correctly, understands architecture, and is the most consistent option available right now. If you're working on a large multi-module project, Qwen 3-coder, because it understands file relationships and full project structure. If you're debugging a production crash, GLM 4.7 for its reasoning capability and stack trace analysis. If you need everything fully local and offline, Llama 4, with realistic expectations for advanced patterns. Add structured prompting to any of these, state your tech stack, your architecture pattern, your target SDK, and results improve dramatically for all of them. And for the best practical workflow, local model for speed, cloud model for architecture. Open source AI has reached the point where, with the right setup and prompting, it genuinely competes with paid tools for Android development. Try it on your next real task. Subscribe for more on AI-assisted development.